The concepts covered are symbols of electric components, heating effect of electric current, magnetic effect of electric current, electromagnet, electric bell. The most convenient source of energy is electricity. Electricity has a very important role because it is used to run many electrical appliances like an electric bulb, television, a stereo system, refrigerator, washing machine, computers, etc., and we cannot think our life without making use of electricity. Electric current is a flow of electric charge. This electric charge is carried by moving electrons in a wire. Electric current is measured as rate of flow of charge. The SI unit for measuring an electric current is the ampere. Electric current is measured using a device called an ammeter. Electric current is denoted by symbol I. In past, it was considered that the current is the flow of protons from positive battery terminal to negative battery terminal through the circuit. Later it was discovered that the current is the flow of electrons from negative battery terminal to positive battery terminal through the circuit. As a convention, current is still considered to flow from positive terminal to negative. Electronic components and their symbols. Electronic component can be an element of an electric circuit that helps in its functioning. Electric circuit allows electricity to flow through it and is used to provide electricity for various purposes such as running electric motors, providing electricity to a bulb or a fan, generating heat. Battery is defined as a combination of two or more cells. In a battery, the negative terminal of one cell is connected to the positive terminal of the next cell and so on. Batteries are used in several devices such as toys, remote control, torches and transistors. Drawing an electric circuit diagram. An electric circuit is a path in which electrons, or current, flow. If the circuit is incomplete or broken, the current doesn't flow. This type of circuit is called an open circuit. If the circuit is complete, the current flows. This type of circuit is called a closed circuit. If the circuit contains some material which does not allow current to flow through it, in that case too, even if the circuit is complete, the current doesn't flow. These materials are called non-conductors. A circuit usually contains a power source, which is the source of electrons, and a load, which is the electrical appliance, like a bulb, needing electricity to run. Switch or key in the circuit is used to make or break the circuit to start or stop current flow. An electric circuit is represented by a circuit diagram. Circuit diagram is a pictorial representation of a circuit with electrical symbols for its corresponding parts. Heating effects of current. When electric current is passed through a conductor, it generates heat due to the resistance it offers to the current flow. Appliances which require heating effect have conductors or the heating elements. Heating elements have high melting points so that they do not get damaged due to the heat generated. These elements have also low tendency to react with oxygen to avoid catching fire. The amount of heat generated in a wire depends upon material of the wire, length of the wire and thickness of the wire. What happens when the filament of a bulb breaks? The filament of a bulb is a coiled wire that gets hot when electricity is passed through it. This makes the filament glow, and as a result, light is produced from the bulb. Production of light in a bulb due to the heating effect of electric current. Many appliances work on the heating effect of electric current, such as electric heater, electric iron, electric stove, geysers, toaster, hair dryer, etc. All these elements produce a high amount of heat when electricity passes through them. However, this amount can change depending upon the requirements of the device. This is so because they contain a coil of wire known as an element. What is an electric fuse? A safety device which works on the heating effect of current and prevents electric fires or damage to electrical appliances due to excessive flow of current is known as the fuse. Fuse is a safety device consists of a short length of a thin wire of tin-plated copper having a low melting point, and this wire has a much greater resistance than the rest of the electric wiring in the house. Miniature circuit breakers, MCBs. This are increasingly being used these days in place of fuses. MCB does not work on the heating effect of current as it works on the magnetic effect of current. These switches automatically turn off when the current in a circuit exceeds the safe limit. We turn them on in the circuit test once again completed. In case of excessive current, the wire of the fuse melts, resulting in breaking of the circuit. Thus, no current flows through the main appliance, protecting it from damage and possible fire. Some of the causes of excessive current are short circuit, overload, excessive current generated from power source, etc. CFL, compact fluorescent lamp. CFLs do not work on the heating effect of electric current. They do not have a filament inside them, instead they contain two electrodes that produce light. These bulbs have a fluorescent coating inside them which makes the light brighter. CFLs save energy as they do not produce heat along with the light. Ordinary bulbs on the other hand waste energy as they get heated while lighting up. An LED light bulb is an electric light for use in light fixtures that produces light using light-emitting diodes, LEDs. LED lamps have a lifespan many times longer than equivalent incandescent lamps, and are significantly more efficient than most fluorescent lamps. What is an IC mark? IC means Indian Standards Institute, which standardizes all electrical appliances. If any appliance does not have an IC mark over it, it means that this appliance does not conform to the standard guidelines of IC and hence it is not safe to use. If any appliance holds such a mark, it means that it is safe to use, it is a quality product, and it will not lead to wastage of electricity. Magnetic effect of electric current. If the electric current passes through a wire, then the current-carrying wire behaves like a magnet. This was discovered by a scientist, Hans Christian Ørsted. He discovered that the needle of a compass deflects when an electric current is passed through a wire placed near the compass. This indicates that a magnetic field is created near the wire that deflects the needle. Electromagnet. It is a magnet made by using electric current. An electromagnet works on the magnetic effect of current. An electromagnet consists of a coil of insulated wire wrapped around a piece of iron which is magnetized only when an electric current is passed through the coil. Applications of electromagnets. Electromagnets are used in domestic appliances such as electric bells. They are used in toys. They are used in all kinds of telecommunication equipment. They are used in cranes to separate magnetic materials from junk and to lift heavy objects. They are used by doctors to remove any magnetic materials that we have fallen in the eye. Electric bell. Components of an electric bell. A coil of wire wound over an iron piece that forms the electromagnet. An iron strip, soft iron armature, which has a hammer attached to it which is joined to the wire coil. A contact screw through which is attached to the iron strip. A battery which connects the wire coil and the contact screw. A switch in the middle of the circuit. Working of an electric bell. When the switch of the bell is on, an electric current flows through the coil of wire which makes the iron piece attached to it act as an electromagnet. As a result, the iron piece attracts the hammer towards itself. The hammer thus hits the bell and a sound is produced. As the hammer moves towards the iron piece, it moves away from the contact screw which breaks down the circuit. As the circuit breaks, the wire coil stops receiving any current which makes the electromagnet lose its magnetic effect. As a result, the hammer falls back to its original position. Then as the hammer falls back, the iron strip again comes in contact with the contact screw and the circuit gets completed. This again turns the iron piece into an electromagnet, and the whole process continues until the bell is switched off. This results in the continuous ringing of the bell.